Okay, so today it says we're going to solve equations by factoring. So what does that mean? So we are still going to factor, but this time we're going to actually solve the equation. So we're going to determine the value. Well, and in this case, when you have a quadratic, there'll be two values for the variable that makes the equation true. So last year you would have done millions of word problems and you had, say, the y value was actually cost. So y equals mx plus b. So what was the cost after so many months of your cell phone, or those kinds of questions? So what we're going to do is we're going to look at solving the equation, and then we'll talk a little bit about the one kind of application of quadratic equations, and then in the next unit we'll talk a little bit more about profit and area, maximizing area, and things like that. Okay, so we read the first point. The solutions to these equations are called the roots of the equation. So we're going to we're going to find the x values, and there will be two of them for quadratic. And we call those the roots of the equation. So you can check your solution by substituting the values in and doing left side, right side, like we have done before. Left side, right side. And, but you do have to factor first. So we are going to, I'll review some factoring here so that we know what we're dealing with. Okay, so the same sort of things that we've been doing for the last few lessons, you have to look for those ideas again. So this first one, you want to, if we were going to factor this one or solve them, you would common factor it first and stuff like that. Okay, so this one down here is a difference of squares, but you'll notice here, instead of saying equals y, they all say equals 0. So that's your clue. Now, the question will definitely say solve, but another clue is that we're looking for the solutions for x that make the equation equal to 0. So when you have a binomial like this, and you're multiplying by another binomial, then if either of the binomials is 0, then when you multiply by whatever's in the second set of brackets, you're going to get 0. So if we had x plus 3 times x plus 1 million, if we put in here negative 3, no matter that this is a million over here-ish, because this changes to 0, when you multiply by this, you get 0. So no matter what's in one set of brackets or the other set of brackets, if you set it equal, if you find the x value such that it makes the binomial 0, then that will, in effect, make multiplying by whatever's in the other set of brackets equal to 0. And that's called the zero product property. Oops, that was not a good highlight, sorry. Okay, so if two numbers have a product of 0, then one or both of them must be 0. So basically, when we're finding the solution here for these equations, we're going to find when the set of brackets is equal to 0. So for quadratics, because there's always a set of brackets, two sets of brackets, with an unknown variable. So whether you have something like this, simple, or something a little bit trickier, in either case, if this first one is 0, then multiplying would make it 0, or if this one's 0, okay? So we're going to find those values. And then in the next lesson, we'll look at equations that can't be factored. How do you deal with those? Okay, so in this case here, we're still, we're going to be factoring. So you want to still try to common factor first. If you get a binomial, which is a difference of squares, like x squared minus 25, then that's where you do, because there's no b term in the middle, so it has to equal 0, so minus 5 and plus 5. And then if it's not a difference of squares and you've just common factored it, that can happen, then you're done. Or you could have a trinomial. So a trinomial would be in standard form like this, ax squared plus bx plus c. So if a is 1, then you can just find two numbers that multiply to c and add to b. But if it's not equal to 1, then you're looking for numbers that multiply to a times c and add to b. And it doesn't matter what you choose, decomposition, magic X, or guess and check. Okay, so this example here is just filled in for you. Okay, so factor, checking for a common factor first. If you want, the steps are numbered, so I'll number them on the left-hand side if you like. So negative 14x squared plus 133x minus 63, you can common factor that. You can divide by 7, which makes the numbers a little bit more reasonable. Okay, so then if you divide all of these by negative 7, then you get 2x squared minus 19x plus 9. So this is number 1, common factoring. And then this is also factoring in here. So they've done decomposition or magic X or check, guess and check, and they found that the two binomials in the factored form are 2x minus 1 and x minus 9. So now once you have the factored form, which is where we've been stopping before, if the question says solve, then you're going to want to set each of the brackets equal to 0. So set each factor equal to 0. So that's this step here. So 2x minus 1 equal to 0 and x minus 9 equal to 0. So again, because of the 0 product property, if this little bracket in here is 0, then whatever's inside this one, doesn't matter, it could be a million. When you multiply by 0, you get 0. Same thing here. If this is equal to 0, whatever's in the first set, it doesn't matter, because when you multiply by 0, you're going to get 0. So with quadratics, so this exponent is 2. That means that you should have 2 solutions or 2 roots. So here we have 2 x values that are possibilities. Okay, so now some of you, when you do a couple of these, you'll notice, oh, I'm just x minus 9. That's obviously, in order to make it 0, it has to be plus 9. We're essentially solving each linear equation. So you have to bring the numbers, like collect like terms, bring the number to the other side, change the sign, and then in this case here, you have to divide. So it doesn't really matter if you would prefer fractions or decimals. You can change it into decimals here. It doesn't matter. Okay. And then when you're asked to check, similar to the first unit, make sure you check because you'll get marks for it. So check your answers by substituting back in the equation. So that's step 4. But then go back to the original, or you'll have to do an extra, like if you use the common factored form, that's fine. You'll just have an extra distribution step. So most calculators, if you plug, say, this in or this in where you've substituted, most calculators can handle that, and you can do it all as one step. That's fine. So you're basically just checking left side, right side. So the right side is always going to be 0. So you're just making sure the left side get your answer to be 0. Okay, so let's do a couple that are not done for us. So you have to factor first. So even though it doesn't say that, we're still factoring. So factor first, including checking for a common factor. But when a is 1, then we're pretty sure it's okay. So we've got x squared minus 2x minus 24. None of those will divide by the same thing. Now, it seems like every single example we have has 24 in it. So maybe you're a little bit better with the factors of 24, but if not, just go through them. So again, yes, I can do 1 and 24, but that's really not going to get us close to -2. 2 and 12, no. but you can write it down. You could do 3 and 8, which is 11, 4 and 6. Now we're getting closer. Okay, so now we have numbers that when you combine them, you can possibly get 2. And when you have this negative, that means, and the negative here, that means that one of them has to be negative. So positive 4 times positive 6 is positive 24, but we want one of them, we want it to be negative. So we want it to be negative 24. So negative 4 times negative 6, or sorry, negative 4 plus positive 6 is positive 2. That's not what we want. So positive 4 and negative 6 gives us negative 2. And when you multiply them, you get negative 24. If you did this without waiting for me, then you could have written the negative x minus 6 bracket first. Same as we've been doing before, and it doesn't matter. Okay, so we're, again, one more time, when you're solving, when the question says solve, then you have another step. So we are finding x when whatever's inside the brackets equals 0. We have 2 sets of brackets, so we have to do it twice. So when is x plus 4, 0, and when is x minus 6, 0. Okay? And if you struggle with solving equations, like manipulating them, then just do it in as many steps as you would have needed back in grade 9. It does not matter, okay? So bring the 4 to the other side. When you do 0 minus 4, then you just get negative 4, but you can certainly show that step as well. Okay, so now we're going to check in both as well. So the left side, negative 4 squared minus 2 times negative 4 minus 24. Again, remembering that that when you do negative 4 squared, that you want to get a positive answer, so it should be 16. Okay, not negative 16. So 24 minus 24 is 0, which is the right side, so we're good. And then let's do the other one. Six squared minus 2 times 6 minus 24. So now we've got 36 minus 12. Oops. Minus 24, so 36 minus 12 is 24. Which is 0, so the right side equals 0, we're good. Oops. Okay, so we're going to factor first. This one does not have a common factor, but it is the special case, the difference of squares. So we're going to square root both. And so we have 3x and 5, 3x and 5. And if we don't have b term, one of them has to be positive and one of them has to be negative. It doesn't matter which. Three x plus 5 equals 0. And divide by 3. So we get the positive and negative version, which makes sense. Okay, so when you go to check this, this is going to be a little bit annoying because it's got a fraction, but when you go to do the check, and if you put negative 5 divided by 3 in your calculator, you're going to get a repeating decimal, which is fine, but that's, again, also annoying to check, right? So here we've got negative 5 over 3 squared minus 25. So when you square a fraction, you square the top and you square the bottom. So you get 25 over 9. So now what happens is you can cancel out the 9s. And then you get 25 minus 25, which is 0, which equals the right side. So in this case here, leaving it as a nice fraction actually makes your life it makes it a little bit easier. Now, this should work the same. Which it does. Okay, not too bad. Okay, so now this one has no common factor, but this is one where we're going to have to do either whether you like decomposition or magic X. So I'm going to do both. Okay, so but really one of the things about doing this kind of factoring, you have to figure out the factors first. So doing this little t-chart is really, it's not that big of a deal. So we're looking for A times C. So 2 times 24. 2 times 14, which is 28. And adds to B, which is positive 11. Oops, not 111, just 11. Okay, so we've got the factors of 28 are 2 and 14, and 7 and 4. Okay, so there's the 11, not that big of a deal. Sorry. So now you decide, are you going to do decomposition or are you going to do magic X? So in magic X, remember you have to divide by the A value and reduce. This one can't be reduced. This one can become 2 over 1. So now we've got this goes first, 2x, and then plus 7. And this will go first, x plus 2 equals 0. If you prefer decomposition. So now we rewrite plus 7x plus 4x plus 14 equals 0. So we write the 11x with the 2 factors and then group factor. So I'm going to factor these 2 and then factor these 2 and hopefully get the same thing, right? So the only common factor in the first set is x. So when you divide by x, you're left with 2x and plus 7. So then on this side, we have to get 2x plus 7 inside the brackets. So the common factor here is 2. So now we are left with 2x plus 7. Oh, it worked. Excellent. So now one of our factors is 2x plus 7, and then the other one is what's ever left over. Okay, so you get the same thing in the end. So you pick what you like to do. Okay, but we still have to do, but now that I've got the 2 factors, I'm just going to do the rest of it together. Okay, so now to solve. So x plus 2 equals 0 and 2x plus 7 equals 0. Bring it over, change the sign, divide by 2. Okay, now we're going to check. So the left side, we got 2 times negative 2 squared plus 11 times negative 2 plus 14. So 2, you have to follow BEDMAS. Okay, so you do the squared first, which is negative 2 squared is 4 times 2 is 8. But again, you should, your calculator, theoretically, you could type this line in and get the answer, okay? So 11 times negative 2 is negative 22 plus 14. So then 8 and negative 22 make negative 14 plus 14 is 0. Okay, so we're good. And then I'll check this one over here. Okay, so now this time, it may make your life easier to do decimals. And when you do 7 divided by 2, you're going to get 3.5, which is not a repeating decimal. So that's kind of helpful, right? So the other one, the disadvantage there was that that it was a repeating decimal, so then that doesn't look very nice. It's harder to work with, and then when you go to check, it might not work out because you've estimated, but here it'll work out fine because it's not a repeating decimal. So you can make that a decimal if you want. And again, hopefully you have a good relationship with your calculator so that you can just type this in. Oops. So to not stress yourself out. Okay, so, but I'll show my work. So negative 3.5 squared is 12.25. 11 times negative 3.5 is negative 38.5. So 2 times 12.25 is 24.5 minus. So now 24.5 minus 38.5 is minus 14. So there you go. It all worked out. Okay. So leave it as a fraction, make it a decimal, and hopefully you've got a good calculator that you've been using that you can just type in that check. But if it doesn't say to check, then on the assignment, then I wouldn't bother with it. Even in the homework, if it's more important you practice more of these, you can check your answer in the back of the book. That's okay, but make sure you know how to check, but don't stress about trying to get it to check if you get the right answer. Especially like over in the other example, if you use a repeating decimal, then it's just got to be close. Okay, so let's do the first type of word problem here. So it says a rock is thrown down from a cliff that is 180 meters high. The function h equals negative 5t squared minus 10t plus 180 gives the approximate height of the rock above the water, where h is the height in meters and t is the time in seconds. When will the rock reach a ledge that is 105 meters above the water? Okay, so this is called parabolic motion. This is a very common formula that you're going to see. If you are into physics, you're also going to see this in there as well. So what happens is the acceleration due to gravity is 9.8 meters per second down. So because today we're going to do it by factoring, then we're going to round it. Tomorrow you're going to see equations that have that acceleration due to gravity not rounded. So then we have to deal with that a little bit differently. But so every time something is like according to the laws of physics, this isn't a theory, it's a law, then everything that is falling towards the ground is going to have the same acceleration. So then we can use that to predict what its height will be after a certain amount of time. So usually we use meters per second, which means that the time's in second and the height's in meters. But normally in a question, it'll tell you, like it says, height in meters and time in seconds. And so what are we trying to do here? So it says, when will the rock reach a ledge that is 105 meters above the water? So we don't really need a let statement because it says h is the height in meters and t is the time in seconds. But we do have to do a little bit of work here. So we are trying to find the value of t, the time, when, right? What value of t, sorry, I don't like that English there. What value of t actually will give a height of 105. Okay, Okay, that's what the question's basically asking us. So that means we're going to set h equal to 105 and solve for t, which is like our x. Okay, so we have this equation. Sorry, that's negative 5t minus 10t plus 180. So in grade 10, you'll be given the equation. In grade 11, I cannot make that guarantee. But like I said, you're going to do so many of these problems that you'll be like, oh, I can figure this out, even whether you take physics or not. Okay, so when we set our equation equal to 110, now we have a problem, okay? So first of all, this is not, it's not equal to 0 anymore. It's not in what we called standard form. And it also has, you can collect like terms, which is not, we usually make them simplified in math, right? But there's not many terms to collect, so we're just gonna, I'm gonna use a different color. I'm gonna bring the 105 over, okay? It doesn't really matter where you put the 0, but because the equation's given this way, then we'll put it this way. It doesn't matter what side it goes on. So now we have standard form, and now we can get to work. So we are going to solve, but we have to factor first. Oops. And especially common factor. So we can divide all these by 5. And now we have this equation inside that's so much easier to work with. So common factoring at first is like, oh, I forgot to common factor. You feel like it's annoying, but it's not, right? Now it's made our equation a little bit easier. So we're going to find, I'm still going to use red, 2 terms that multiply to negative 15 and add to 2. So right away, your brain might already be screaming 5 and 3, 5 and 3, right? You've done so many of these questions. 1 and 15 is not going to work. We want 3 and 5, and because we want a negative answer, one of them has to be negative, and we want our answer to be a positive when you add, so the bigger number has to be positive. Okay, so now we have our 2. I'm going to write over here. I'm running out of room. Sorry, guys. Over here, solve. So we have t minus 3, oops, equals 0, and we have t plus 5 equal to 0. Okay, so when we rearrange that, you get positive 3 and negative 5. So this is going to happen in every single parabolic motion kind of question. You're going to get this situation here where we have 2 times. So how do we know which one do we use? Well, negative time implies that we can go backwards in time. You can't do that, okay? So you can't use negative time ever. In physics, in math, never, ever, ever. Can't use negative time. So when you do this, one of your answers will be positive and one of your answers will be negative. So if you don't get that, that's another clue. Whoops, I think I made a mistake. I have to go back. So let's write an answer statement. The rock reaches 105 meters at time equals 3 seconds. Okay, so there's the homework there. The The first pages are more practicing this, and then the next pages have some word problems. So even though they're kind of similar, make sure you take a look